So we were going to discuss about the double differentiation, maxima and minima, but there's a slight change. We are going to learn sum rule, difference rule, the product rule, quotient rule, and the most importantly, the chain rule. So these are the most crucial rules in differentiation. So let's start. So the first one is the sum rule. In the sum rule, if we have a function which is s of x maybe, and it says that what is the derivative of s of x when s of x is say x cubed plus x squared. So you know how to derive x cube by the sheet I had given you, this one, and by this formula you know how to derive x cube and you know how to derive x squared. But what if you are given the sum of both the functions? So here comes the sum rule. If you have two different functions, treat it as two different functions altogether, which is kind of funny. I said it as a funny thing, but it's easy. So say f of x is x cube and g of x is x squared. So what is s of x? It is f of x plus g of x. So according to the sum rule, the derivative of the s of x function will be the sum of derivatives of the two functions, and which is easy. So even if there are many functions, say plus t of x plus blah 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 blah, so which is not in this case, so it will be the derivative of the function, the sum of the derivatives of the function. So it will be the derivative of f of x plus the derivative of g of x plus the derivative of the blah blah blah. Yeah. So in this case, the s dash of x will be the derivative of f of x. So what is the derivative of f of x in this case? It is the derivative of x cube, which is 3x squared. And what is the derivative of x squared? It is 2x. So the answer is simple. It is 3x squared plus 2x. So this is the derivative, and we found it using the sum rule. It was easy, right? So intuitively you might predict that if the sum rule deals with something called the addition of the two functions, the difference rule must be something called the subtraction of the two functions. If you're thinking so, you're absolutely right. So let's move on to the next rule. So this is the difference rule. If you have the same function which is say s of x, sorry, yeah, so this is s of x. So what is s of x? It is x cube minus x squared. So pay attention to the minus sign here instead of the plus sign, which was in the last sum rule. So this is the difference rule. So you have the two functions which are subtracted. So this is the difference between the two functions. So you can derive the two functions. So you just treat it as two different functions altogether. So you have f of x is x cube and g of x as x squared. So what will be s dash of x? It is similar to the sum rule. It is very easy. So this will be the difference between the derivatives of the function. So this will be f dash of x in order, because you have to follow the order, because here it is the difference. It's easy. So minus g dash of x minus the derivative of blah blah blah. Yeah. So in this case it will be the s dash of x will be the derivative of f of x, which is 3x squared, as we discussed earlier, minus 2x. So this is the answer. It was very easy. Next comes the constant multiple rule. It is known by many names in different books, but it's pretty much the same. The name doesn't matter. They have given some weird names to these, but don't get scared by the names. It's very easy. So if you have a function which is 3x squared, so how will you deal with the function? You just have to the derivative of x squared, but what about the 3? So you just treat it outside, you take it outside the function, and you just derive the second function. So say this is g of x, you treat it as a different function altogether. So g of x is x squared, so this the f of x will be 3 of g of x. So there is a simple multiplication sign here. So this is 3 into g of x. So what is the value of f of x? It will be 3 into 2x, because the derivative of x squared is 2x, so it will be 6x. So this is the answer. It doesn't say anything. It is very easy. It just says a very simple thing, that if you have a constant, which is 3 is a constant, so 3 is a constant, so you can take it outside, and then later you can multiply it with the derivative of the function which you have to derive. So x squared is the function in this case. Next rule, we cannot call it as a rule. I feel awkward when I call it as a rule, because it is so easy that I don't think we should call it as a rule, but we have to. So it is a constant rule. So the constant rule says that if you have a constant as a function, so f of x is say a constant, c, or else I'll tell you some other uh, definite or specific constant. So I'll say that f of x is phi. So intuitively you can draw a graph in your mind, in which the y axis, the y coordinate will always be phi, irrespective of the x coordinate. So it will always be phi. This is the phi, yeah, and it will always be on phi. So we know that the derivative is just the slope of the line, and here as we can see, the slope of the line is 0. So if we have a constant, in this case it is phi, then the derivative, the f dash of x, will be 0. This is just the rule. And if you want to take a screenshot of the sheet, you can take the screenshot of this sheet right here, which tells all the rules, which is the sum rule, the difference rule, the constant multiple rule, that is such a complex name given to it, but a very simple rule, and the constant rule. We'll look at the product, the quotient, and the chain rule in the next video.